Okay, on separate axes, sketch the graphs of y equals minus 3x plus c, where c is a positive constant. Okay, let's start with that one. So down here, use pencil. Pencil doesn't show up, so you're going to have to deal with this. So there we go. We have our set of axes. So separate axes, we've got minus 3x plus c. On each sketch, show the coordinates of any points at which the graph crosses the y-axis and the equation of any horizontal asymptotes. Okay, so for a straight line graph, which is the first one, which is the negative gradient, we obviously don't have any asymptotes. If I was to find, we only want the y-intercepts, so put in x equals 0, and we get y equals c. So if I just put that on there as 0, c, then all I've got to do is draw myself a negative gradiented straight line. Okay, and that'll do. It doesn't want any other points. It doesn't want the points where it cuts the x-axis, so that's pretty good. Okay. Okay, so the next one, let's have a look. We have y equals 1 over x plus 5. So let's get ourselves a second set of axes drawn down here. Ooh. Label them y and x. Please do remember to label them. So we've got, I'll just write it down next to it for a second, and we'll probably need to do a bit of maths with this one. So y equals 1 over x plus 5. Again, I'm just going to, we can put in some numbers really. Only once the equations are where it cuts the y-axis. So if we were to do that, we'd put in x equals 0, and instantly you can see that we've got a problem. 1 divided by 0 is just, we don't do it, it's indeterminate, so it can't be true. So actually there's an asymptote on the y-axis, but it doesn't really matter. It doesn't want it, but it's good to know. It's going to aid in our sketch. So I'll make a note of that. So asymptote on the y-axis, which means it's not going to cut the y-axis, but yeah. And then we have a horizontal asymptote. Okay, and this one is a little bit harder to figure out, but it should be fairly not obvious, but we can see that if we just looked at the y equals 1 over x graph, we know that as a rough sketch it looks like this. That was bad, but you get the idea. So what I'm going to do is I'm just going to add 5. If you remember that add 5 just kind of shifts this whole graph up 5, and then we can start to see that that's where our asymptote is going to go. So we cannot get an answer of y equals 5. Okay, looking at the equation, we should kind of be able to see that if you take 1 and divide it by any number, no matter how large, it's always going to have a value. So you can get very close to 5, but you'll never get there. So this idea of an asymptote being at y equals 5 should make sense from our graph. And then I'm just going to redraw this, hopefully a little bit nicer, but we've got an asymptote here as well, so it should go like this. And it should go like this. Okay, so there's my graph. Not a work of art by any means, but there we go. Good. Right, so now we've got the next bit. Given that y equals negative 3x plus c, where c is a positive constant, meets the curve y equals negative, no, 1 over 5x plus y equals 1 over x plus 5, sorry, at two distinct points, show that 5 minus c squared is larger than 12. Hence, find a range of possible values for c. Okay, so let me just get another piece of paper. There we go. So let me just put this to the side so I can still read from it. Don't need a spare, just need the lines. Okay, so let's write it down. So y equals negative 3x plus c meets the curve y equals 1 over x plus 5. If I quickly sketch in here, this should make sense on what's going on. We have ourselves the straight line and the curved line. It's going to cut, you can see it's going to cut twice. Yeah, so we're expecting 2 positive values of x, but we don't have that yet, so that's why we're going to find a range of values. But anyway, yeah, sorry, don't just a bit sidetracked there. So what we're going to do is we're going to equate these two. If they're equal, they intersect even. So let's put these equal to each other. 1 over x plus 5. I'm going to get, times it through by that x, just to make it a bit nicer. And then I'm going to write that out. So minus 3x squared plus cx equals 1 plus 5x. Alright. I'm going to put it all on one side, and I'm just going to get it equal to 0. I've got a quadratic. I quite like my x squareds to be positive, so I'll move it all over there. And I'm going to gather my x terms. So if I do that, I'm going to get 3x squared. This is c is now going to become negative. So I've got plus 5 minus c x plus 1 equals 0. And you can start to see where the answer's kind of disappearing. Not disappearing, appearing even. Oh, I can't talk tonight. Show that we've got that 5 minus c squared there. So what I'm now going to do is I'm going to have a look at the discriminant. Okay. The reason I'm going to do that is it tells us specifically that it cuts at 2 distinct points. So my discriminant, b squared minus 4ac, has to be larger than 0. Okay. So let's just put in all the information. A is 3, b is 5 minus c, and c is 1. So let's put that in. That gives us 5 minus c all squared, that's our b squared there, minus 4 lots of 3 lots of 1 is larger than 0. Or you can see that this becomes 12, and just moving that over to the side there, this quite clear gives us 5 minus c squared is larger than 12, which is exactly what we're asked to show. Okay. Ooh. So we've nailed that one. So next, C. So let me just put this back in front. Ooh. We have, what's the question? There we go. Hence, find the range of possible values for C. Alright. There's a couple of ways There's a couple of ways you can go about this one, really. And which way should I go about it? You could go about it in, this is a quadratic in C. So you could go about it in a quadratic inequality. Yeah, do you know what? I'm going to go for a quadratic inequality. So let's square this out, and I'm going to get c squared minus 10c plus 25 is bigger than 12. Subtract that, and I'll just get c squared minus 10c plus 13 is larger than 0. Alright, so I'm going to be looking for these critical values. Quick sketch over here. So these are my critical values. This might be a bad sketch, I don't know. Larger than 0, I'm going to get an inequality larger than this point and smaller than this point. So we just need to figure out what these critical values are. And we do that just by solving it as if it was a normal quadratic equal to 0, which is what I'm going to do. It doesn't factorise nicely, so I'm going to use the formula, and I'm going to get minus b, which becomes minus 10, plus or minus the square root of minus 10 squared minus 4 lots of 1 lots of 13, all divided by 2. Okay, so in here this is 100, take away 4 lots of basically 13, which is 52, and I'm going to just divide this through as well, so this becomes, sorry, that should say C equals, okay, so therefore C equals 5 plus or minus the square root of 100 take away 52, was it? Yep, so 48 all over 2. Well, I'm pretty sure we can find a square number that goes into 48. I reckon that is 4, so this becomes 2 root 12, but 2 root 12 over 2 is just root 12, so we've got C equals 5 plus or minus the square root of 12. And actually, now that I've done that, it probably would have been easier just to square root this answer of 12 over here, to get the plus or minus 12 and then subtract the 5, but what can you do? So now we've got our answer, and remember our little diagram here, so this bit here, this is quite clearly larger than 0, this is smaller than 0, and this is larger than 0, so I want these two answers tending away from these critical values, so I think I want everything that is larger than 5 plus root 12, as that's obviously this one, and I want everything smaller than 5 minus root 12, as this is obviously the lower of the two critical values. And there we go, that's it.